Hello, Professor. My name is Zarin Cherry, and this is my individual presentation for Project 1. For this project, we worked on something called the SQL Noir Mystery Project, where we used SQL queries to investigate and solve different mystery cases in the Northwind database. Each case represented a real world business problem that could be uncovered through data analysis, and my job was to write SQL queries that would help solve those mysteries. I'll be going through all 7 cases that I completed and explaining what I did, what results I found, and what those results actually mean. So this is my case 1. It's called the phantom shipment. So the first mystery was about orders that seemed to have shipped before they were even placed, which obviously shouldn't happen. To solve this, I wrote a query that compared the ship date and order date columns from the order table, filtering for any cases where the ship date was earlier than the order date. I also joined the customers table to see which customers were linked to these suspicious orders. So after running the query, I found that no records matched the condition. That means there were no phantom shipments, the data is clean, and all shipments happened after the orders were placed, just as they should. This first case was pretty simple, but it really helped reinforce the idea of data validation, making sure that the data makes logical sense in real world terms. And this is my case too. It's called the duplicate address conspiracy. So I worked on a case about customers with the exact same address, city, and country, which could mean fake accounts or duplicate entries were made. I used a self join on the customers table to match customer A's address with customers B's address, making sure they were in the same person. If two different customers shared the same address, they'd show up in the results. So when I executed it, I got 0 results again. So no suspicious duplicate addresses were found. That's actually good news because it means the customer data was consistent and didn't contain any accidental or fraudulent duplicates. And this query helped me understand how self-joins are useful when you need to compare rows within the same table. Case 3, the bulk buyer. Case 3 was more interesting. I had to find customers who made huge orders, meaning total quantities of 200 units or more in a single order. I joined the orders table with the order details table, grouped the results by order ID, and used the sum quantity function to total how many units were in each order. Then I used the having clause to show only those that had totals greater than or equal to 200. This time the query returned 21 rows. The biggest buyers included companies like Ernst Handel, Save-A-Lot Markets, and Quick Stop, all with large bulk orders. In a real business, those could be legitimate wholesale transactions, or they could raise red flags for fraud detection or inventory review. This case taught me how to use aggregate functions and filtering to find patterns in sales data. Case 4, the price spike. This mystery focused on checking whether any products were sold for prices that were unusually high, specifically 30% above their listed catalog price. To do this, I joined the products table with order details and calculated the average sold price for each product. Then I compared that to the regular unit price in the catalog using a formula that shows the percentage difference. If a product was being sold at 30% higher than its original price, it would show up in my result. After running the query, I didn't find any products that fit that condition, meaning there were no price spikes in the data. That tells us that Northwind's pricing was consistent and that there weren't any errors or overcharges happening. Case 5, the employee lag. This one was about figuring out which sales employees took the longest to get orders shipped out after they were placed. To solve this, I used a common table expression or CTE, where I calculated the number of days between each order's order date and ship date using the date diff function. Then I averaged those values per employee to see who had the lowest average shipping time. When I ran the query, the results showed Ann Dodsworth at the top with an average delay of around 10.85 days, followed by Michael Soyama and Margaret Peacock with slightly shorter averages. In a real company, this could mean that Anne handled more complex orders, or it could signal a need to optimize her workflow. This case showed me how SQL can be used not just for retrieving data but also for evaluating performance metrics. Case 6, the category imposters. Case 6 was fun for me. I looked for products that sound like beverages but weren't categorized under beverages. I used the like operator to search for product names containing words like tea, coffee, juice, soda, or milk, then filtered out anything that already belonged to the beverages category. I found one imposter product, Tea Time chocolate biscuits, which was categorized under confections instead of beverages. That one makes sense. It's technically a snack, not a drink, but this shows how naming conventions can cause confusion in databases if categories aren't consistent. This mystery helped me see how SQL's text matching tools can be used to clean and organize data properly. And then case 7, the silent supplier. The last case looked for suppliers whose products have never been sold, kind of like ghost suppliers. I used a subquery with not exists to check for suppliers that don't appear in the order details table through their products. If a supplier had zero sales history, they would show up in the results. After running the query, I got no results, which means every supplier in the system has sold at least one product. So there were no silent suppliers in the database, everything was in active use. This final mystery was a good practice in using nested subqueries to detect missing relationships across tables. Before I wrap up, I also want to talk briefly about how this project connects to the NACE career competencies, which represent the key professional skills we're developing through this course. Our SQL NOIR project highlighted 4 main areas: critical thinking, technology, teamwork, and communication. So for the first one, critical thinking, every one of these 7 cases required logical reasoning and step-by-step problem solving. I had to analyze relationships between tables, think through how data was connected, and decide the best SQL structure to get meaningful results. For example, comparing dates in case 1, detecting duplicates in case 2, or evaluating averages in case 5. All of those required critical thought and reasoning, not just memorizing commands. This project definitely strengthened my analytical thinking when working with real world data. Technology. I also gained hands-on experience using Azure Data Studio and connecting to the Northwind database. I learned how to write and debug complex queries, use grouping, joins, subqueries, and CTEs, and execute them in a professional SQL environment. We also organized and pushed our work to GitHub, creating a shared repository with folders for notebooks, recordings, and images. This process helped me practice using modern tools for database management and collaborative version control, skills that are valuable in real data jobs. Okay, and then teamwork. Even though this is my individual video, our group worked together throughout the project using GitHub. We helped each other fix errors, review queries, and merge updates to the main project folder. It was like pair programming. We discussed logic, confirmed results, and made sure everyone's notebook ran correctly before final submission. Working as a team taught me how important collaboration and organization are when working on shared technical projects. Okay, I just want to show the NACE chart we made. Okay, and this is the chart. So I'm up to the communication part. Finally, communication was a big part of this assignment. We didn't just write SQL code, we had to explain our reasoning clearly in both written markdown cells and recorded presentations. This video walkthrough, for example, is meant to demonstrate not only that I can solve SQL problems, but also that I can explain them in clear, easy to understand language. That's a skill that's crucial in the real world, where you often have to present technical results to non-technical audiences. So this was critical thinking, teamwork, technology, and communication that I just explained for our niece. Okay. Overall, this project helped me grow both technically and professionally. I improved my ability to think critically through data problems, apply SQL to real world questions, use professional tools like Azure Data Studio, dbeaver for getting the results, just for executing the queries, and GitHub, collaborate effectively with others, and communicate my findings clearly. It was a really rewarding project because it connected what we're learning in class to real world career skills, and it showed how data analysis can be both logical and creative. Thank you so much, Professor, for watching my presentation.